Example 3 seems to be a inverse design problem. Okay, you have a T-shaped beam as shown here. It's supported as shown in this figure. It's an overhanging beam. Okay, the space S is 4 inch. Then we know that each screw has the allowable shear force capacity of 480 pounds. So what is the maximum allowable load P? Here you have two external loadings. It's 1P at point A and 2P at point C. So you are determining the allowable load P. Okay. Normally, we need to use the external loading P to determine the V values. Then we can do the 5 steps. Right? Since V needs to be determined in the first step, if we do not know P, we have no way to know the value of V. So what can we do? Actually, we can just assume the P is a constant, but it's actually an unknown variable. We can carry this variable to do these 5 steps, and in the final step, we solve an equation. So this is the overall strategy. Right? Clear? Then, okay, we just do these 5 steps, okay, one by one. So in the step 1, we're calculating. In step 1, we're calculating V. Right, but how to find a V? We need a free body diagram. It had been shown here. So based on the free body diagram, we can solve the reaction forces and then draw the V diagram. Right? So it's not hard to do. The overhanging beam, you already know its loads and the By and dy. So from equilibrium, you will know that By plus dy equals 3p. Right? And then from, this is your equation 1. Then from sum md equals 0, right, you can get the By times 2L1. L1 is 5, the 2M1 is 10, equals P times 2 times L1 plus L2, that is 13, right, plus 2P times L1, that is 5. So you can easily solve that By. This is the equation 2. Right? You can solve that the By is 2.3p and the dy is just 0.7p. Okay. Based on this result, you can draw the V diagram. Okay. The V diagram starts from here. It's a negative p. Right? Since at point A you have a downward p, you start from a negative p to By. Then at By you have a concentrated load, the By, that is 2.3. You will raise it to 1.3p. Right? Then to point C is 2p, the minus 2p, you get a negative 0.7p. Right, to the end. So here you get negative p, 1.3p, and negative 0.7p. Right, so what is the maximum V value? So the V max can be determined from here. It will be 1.3p. Then step 2, we're calculating Y bar and I. So I will skip this step, right? So we can calculate the Y bars, the 2 small tables, right? Since you have only 2 sub areas. So Y bar is determined as 2.83 inch from bottom. So this is the global centroid, meaning that here y bar equals 2.83. And I is determined as 113.5 inch to the fourth. Step 3, we're calculating Q. I equals AD. And the area we isolated is just right here. This is the area we isolated. And the local centroid right here. So what is the D value? Right? The A obviously will be, here is 7.5 and here is 1. Right? 7.5 times 1. And the D will be y bar minus half of the thickness. Y bar is 2.83 minus 1 over 2. So you got 17.48 cubic inch. Step 4, we're calculating shear flow. That will be VQ over I. And the V is 1.3 P times 17.48 over 113.5. So you got 0.2 P per inch. Okay. So the regular step 5 will be M V pin larger than QS, right? So here we have know the V pin, right? It had been given, as shown here. The V pin is 480 pound, right? So here we can write that the Q is smaller than M V pin over S. Okay. So in this equation, what is the value of M? Okay, you have only one row of pins, of bolts, nails, okay? Then this M equals 1, right? S, 4 inch, right? So here you can just do this calculation. Okay, I will skip this calculation, then you will get, no, let's write it here, okay? Q is 0.2 P smaller than 1 times 480 over 4. Okay, so it's easy to calculate that the P, well, here is right hand side will be 120, so P will be smaller than 120 times 5, that is 600 pound. Okay, so this is the maximum allowable load P that can be added as shown here.